Okay, so we left off last time with kind of bringing in a lot of this actual game imagery here. So we have some of the issues I mentioned are just the different sizes of things are way out of proportion. Like the bullets are bigger than the enemies or the player. Other things that are an issue is we have our collisions don't really work that well. As you can see, I can't get the update over here unless I go to the top left. So some of the things that we're fixing here in these next two episodes, 18 and 19, is collisions. We are also resizing images, and we're going to change the programming here for the bullets. A part of the issue was that right now there wasn't any way to keep track of whose bullet was a whose. So was it an enemy that shot that bullet or the player that shot that bullet? Because even though probably not how bullets work in the real world, but we're not having friendly fire. So if I shoot a bullet, it shouldn't affect me. It should only affect enemies. If an enemy shoots a bullet, it should only affect me as the player. So take a look at where I ended up here. Maybe, there we go. So obviously we've kind of created a map too as well. So that's one of the other big things. And if I find an enemy here, it actually doesn't change my HP if I run into an enemy or collide with them. It only does if I hit an enemy's bullet. So that's some other things. And let's just actually take a look at the code here. So where do we start? Let's start with how we resize the image. So that was in the entity draw function here. If this is going to work for me, it's slow right now. There we go. So self.draw. Before we, I believe, only had a self.image, an X and a Y, and we had it kind of, ending right here. So those were the only parameters we gave it. So what we did now is there's more parameters. There's a similar function here, a polymorphic one actually. So I could only use three parameters. I could tell it to what image to draw and put an X and a Y value for where to draw it. But I can also use a different version of that function where I give it more parameters. So I will tell it what image to draw, and I will tell it where to crop the image. So here, what this pretty much means is if I have my enemy or I have my map, okay, I don't know why I did both of those, but whatever. Well, when I'm doing my enemy, I don't really want it to crop. I just want to see the enemy. So I'm actually not going to crop it. I'm going to start at 0, 0, which we should have noticed in the code for my entities, whether it's a upgrade, an enemy, the player, doesn't really matter. I'm going to start at 0, 0, which is the top left of the image. And then I'm going to go to self.image, and there's a property in the image called width. So it knows how wide this picture is. So it's going to start in the top left, and it's going to go to the width, which is over to the right, and then it's going to go to the bottom, which is the height. So it's going to include the whole image. So I'm actually not cropping it when I have it written like this. Starting at the top left, and these two tell me to go to the bottom right. And then the next part is where to put it. So I'm going to put it at X and Y, whatever position that thing is at, and how far to draw them. I'm going to draw the whole thing. So I used self.width and self.height, which was a function that we store in whatever entity it is. So let's go to, where do we go? Okay, actor. So I have a height and a width, and I pass that to the entity. So I was already in the right place. Okay, so you specify that. before how we did it, like with enemies, you remember it was like random, the boxes that went around, the red ones were all different sizes. So we actually had to change that code, which was in like the randomly generate enemy. So before, this was right here was a function similar to this, where we had a certain minimum size and we added a certain random value to it. What I did was just change them to the size of the image, like how many pixels they were. So I hard coded it in. So that lets me, like, let's take a look at this. Let's mess around with it and let's, I don't know, make this some ridiculous number. 200 to 200. And this is my enemies. So let's take a look at how this affects it. Okay. So just by making that one little change there, I actually made the enemies way super big. So that's how that can easily affect the size that they're drawn. It can blow them up, it can zoom them in, anything like that. So you can just mess around with those numbers. What was it? 64, 62. Okay. And figure out what size you want your enemies to look like. So obviously these images were pretty small, so they kind of look very pixelated when you blow them up a lot, but in reality you can make them whatever size you want to. So that's how I kind of coded in that thing there. And remember, this draw function used to potentially be kind of rewritten multiple times. But since I'm doing this in the entity includes my player, my upgrades, my enemies, and my bullets. All of them need to be able to draw themselves. This one function is going to work for all four of those different things without any special changes because I'm using these general self terms and all of them have X's and Y's and they all have the parameters that you need, the values you need to be able to draw them with this same function. So that's why this whole inheritance thing is important. It lets you make one change here and it's going to do that function for all of the things in the game. Makes it pretty easy to update and make better. So that was the drawing the images. What else did we change? The map. So I think that was actually in the test game. So we made a function here. We actually made a constructor technically. This constructs a map object and I created the object and stored it in current map and I called the constructor. So I passed in an ID, we just called it a field. I gave it the location of the map file, so image/map.png, and I gave what I'm assuming are the pixels size of this image. I wonder if it can tell us that anywhere. The video just had it, those numbers hard coded, and I didn't look into it, but it should. Okay, 640 by 480. That's a little bit bigger, but it's just double. Okay, so I did doubled the size of the map. So once you pass those in though, what we do is we create this map variable, this map object, and it's got a bunch of variables within it. So it's got an ID, which you can just use it to refer to which map you're talking about. This pretty much means that we're building a function here that lets us have more than one map in our game. We're creating a new image. We haven't told it what image to use yet, but we're just saying that, hey, we're going to have an image. Let's create a new one. And then we give it the width and the height that we tell it right here. So first thing I did is I set the image source. So the image source is coming from the parameter that I passed to it, which is image/map.png. So that actually loads in the image that I've been showing here a couple times, this one. Tells it where to look for it. And the draw function. So now I have a draw function for my maps. It's the same name as my other draw, but it doesn't use those functions we were just looking at above because it's within this map structure here, this constructor for the map variable. So I created an X, and I take the width of my screen, the canvas, the box that the game happens in, and I divide it by 2. And then I subtract the player X from it. Okay. The height divided by 2, subtract the player Y. So where this comes in and why we have it set up this way is we're kind of giving it the width divided by 2. Why width? X. So the X is going to get higher as you go to the right. It's going to get quite high eventually. To be perfectly honest, I'd have to look into why it's the width divided by 2 and the player dot x, why we subtract them, but it clearly works. Because the width is 500, and you're going to end up with negative numbers as you move to the right a lot. So if you go over 250, you're going to end up with negative numbers, and I don't know how that really helps you out too much with the map itself. So CTX draw image, we draw the image itself, which is the map, because it's self.image. It's going to be whatever you put in here. It's 0, 0, so we're going to start in the top left, and we're going to crop it to the image width, image height, so I'm not really cropping it anymore. But then I'm only going to draw a certain chunk of it. So I'm going to start at the X and Y, and then I'm going to go to the width of the image times 2. So self.image.height tells you the height of the image, and I'm going to multiply it by 2. Okay. And then returning self just means that you actually return something to this value here and can use it later on. If you don't have the return self, you would have run all this code for no reason because you would have done all this stuff, but you wouldn't have stored it anyway. Because this current map says it's going to equal maps. If you don't return anything, there's nothing to set this equal to. So you would have run all this code for no reason. Okay. And where this comes in, it's an update function, which is up here. So right after I clear my canvas, I update a couple variables there, but then I draw my map. And then I'll go through and I'll draw all of my entities on the game. So every time it updates, it redraws the map based on where the player moved, pretty much. Okay. Now, that took care of the map. There's a few things I still want to try to figure out with what the actual logic was for using those variables down there, those values. The other thing that we did was collisions. So that is in the actor, oops, I'm not in entities. Yes. Okay. Another thing we did before we get to the collisions, I just saw it here, is before we used the width of the canvas for a lot of these things that I have in here that are called current map dot whatever. And what happened before is in this game, we have giant still. So as soon as I come here, this is centering the player in the middle, and really it's the map that's moving, not the player's position on the screen at least. But once I got to right here, so this is as far as I could have moved. because I used the width and the height of this box, this canvas. And I wouldn't have been able to go over all the way to the other side of the map. So I would have been stuck in the top left corner. So what we did is we created a difference between the width of the canvas on the screen, this box here, and the width of the map. So what you can do then is you can just, instead of the width, you can go through your code and search for different parts where you used this width, the one with all caps, which means it's a constant usually in coding when you use all caps, and you replace it with current map.width. And I did that for the player here, figure out where it was, did that with enemies, and I did that with the upgrades. So once I changed this, no longer were we stuck in that top left part of the map. We could go anywhere on the map before we bounced, or we could be generated in those different places, all sorts of stuff. So test collision, there we go. Nope, that's a different one. I don't even think that it is used, but that is not where I changed it. Okay, one of the things that I see that I took out here, I commented out. This was the part of the code that actually tested to see if the player was colliding with what they say is self here, but since we're in the enemy function, it is testing to see if you hit an enemy. If you did hit an enemy, it took away an HP. So I took this out. I didn't delete it because who knows, maybe I would want to use it again. So I just commented it out with these block comments here where I can take out everything between these asterisks and slashes. So we don't want to take away HP anymore when we hit an enemy itself. We want to only do it when we hit a bullet. So let's take a look here. Form attack. Is it an entity that we have the collision? It's player test collision right here. Okay. Where's this actually at? Let's see wherever HP is. Okay, there we go. It is in the bullet. So we have two things that we did here. We added a combat type to the bullets. So before we didn't have this, and there was no way to distinguish or tell the difference between a bullet that a player shot or an enemy shot. Now with the combat type, when we create this bullet, all we do here is equals combat type. So when I actually do my attack, which is in the actor, okay, perform attack, I generate a bullet and I set it equal to self. So that means that when I generate that bullet, where is generate bullet at? Okay, I have my actor here, so whoever shot that bullet, and actor.type. So actor.type, if it was a player, is going to return player, and actor.type, if it's an enemy, is going to return enemy. Because we literally created those variables and we did things like this, enemy. So that's what the type is. So now if it's a player, if the type is player, combat type, then we do the stuff that this means that the bullet was shot by the player, I guess. which means we go through every enemy and we see if we're colliding with it. This is the exact same thing that we did earlier in the game. So this is the same code, I just put it in this section here for player bullets. If an enemy shoots a bullet, which is this section down here, all we have to do is test it with the player. We don't need to test the enemies or anything else. So if self.test collision is the player, then you take away 1 HP and you remove the bullet. So you get rid of it because it's already been used. Okay. And what else was there? Pretty sure that was most of everything. So the other thing that actually got kind of fixed for us was that weird bit where I could like go underneath the upgrade and it wouldn't collect it. When I started drawing the image with a certain height and width, which were already variables in my code, I actually fixed it on its own automatically. Because before I was already using width and height to draw the rectangles at different sizes. So if it was this width and height, it would draw a rectangle that big. If it was more of a square, it would do one that big, and you would test that area. So now that we actually draw them with a width and a height, which are variables that we set for our entities, it automatically took care of that problem we had. Okay. I think that was everything that pretty much happened in this episode. So we now have a map. The player kind of sits in the middle of the screen. We now actually can wipe out enemies with bullets. Bullets take away HP instead of collisions with enemies. And there's different kinds of bullet types at this point. So my bullets will hurt other people, but not me. So it's not taking me away my HP. But if I run into an enemy's bullet, it will take away HP. I think what they said the next couple episodes are going to do is kind of develop AI or artificial intelligence for these enemies. So they don't just randomly go around the screen. They can detect where the player is, be able to shoot towards the player, and even follow the player around. So that's where I think we're going next.